Howdy! This is your friendly neighborhood physics teacher here. This is the 5th video of your spring final review. You've missed 4 more. If this is the one you're starting with, I did torque, momentum, 2D motion, and waves so far. Now on the torque video, since that's the first one, I go over in a little bit more detail exactly what to expect in the test itself. Let's dive into the nuclear part of the video. So again, this table goes at the beginning of your review. This will be your variables, your unit, and equations. So energy is represented with an E. Your variable is what goes into the equation. Your unit is what goes behind the number. So it's represented with joules with a J, and your equation for energy in nuclear is E equals mc squared. Mass is represented with a letter M, and it needs to be in kilograms. Your speed of light is constant, so that is c. And your speed of light is 3 times 10 to the 8th meters per second, or 3e8 meters per second. I would know that. You need to know that. That will not be given. You need to know that. That speed of light is 3 times 10 to the 8th meters per second. 3 times 10 to the 8th meters per second. I would know that. Okay. So going into nuclear information. So question 1. The Young's double slit relies on what? So that's like the double slit experiment. This is the experiment that they were able to realize that light has a dual relationship. It's considered a particle and it's considered a wave. So light does have mass, but what they use that for is interference, because if you're thinking about it, has 2 slits. So you have 2 slits and you have waves. If you have a wave coming at it, if you remember anything, once it starts going to a slit, you have getting that D, that curve aspect of it. And remember, that's called diffraction. And if you have 2 going in, eventually those waves are going to start crossing over. And when those cross, you have that interference. So having that double slit has the main thing, what you're able to see that it is a wave and the fact that it is a particle is interference. Interference. Y'all know I can't spell, but close enough. So it's interference. So why a Young double slit even worked is because they could see that interference with the waves and how that wave reacted, so you could see that it's a particle. So that kind of goes into number 2. What does it mean for light as a dual relationship? It is considered both wave, so therefore energy, and it's a particle, so it has mass. So it has both wave and particle aspects. It kind of lives in both worlds. Instead of, waves just move particles around. Light itself is particles, and that's why it's able to move through a vacuum without using particles, because it is its own particle. It doesn't need a medium because it is its own medium. Another explaining why it can't go through solids, because it's its own particle. It'd be kind of sitting there, I use the excuse of trying to move through a crowded hallway. You need to get a point A to point B. If it's empty, it's a whole lot easier to move through. If you're trying to get through and there's fellow students in your way. Number 3, why do elements produce different emission spectra? So if you know anything, so you have your nucleus here, and then call that N for nucleus. And in the nucleus, you have, protons and neutrons and all that fun stuff. But then you have your electron cloud. And that's where your electrons chill. That's where your electrons chill. Anytime you have an electron that moves from inner to outer or outer to inner, moves different levels, it gives off some energy. It gives off some energy. It gives off light. And with that giving off, because it takes energy too, so it's like poof, has that spark of light, and its own electron gives off a certain color. So if it's going up, it'll give a certain color. If it's going down, it's giving a certain color. So that emission produces its own energy, it produces its own light, and you're able to see that movement. So each element, because where that electron is it in the first, second, third, all that different cloud, electron cloud is, it will produce a different color. So that's why each element produces its own electron spectrum. 4. How much mass does it take to produce 3.404 times 10 to the negative 15 joules of energy? And we're looking for how much mass. So if we're going to do our givens, so we're dealing with energy, so we know speed of light is 3e8 meters per second. It gave us that energy is 3.04 e to the negative 15 joules, and our unknown is mass in kilograms. So the equation we're going to end up using is E equals mc squared. Our E is 3.04 e to the negative 15 equals, we're looking for mass, and our speed of light is 3e8 squared. Now, again, this is the point in time I would raise my hand and make sure I have a graphing calculator in hand, because you can actually use the e's. So you would just type in, before I do that, let's go ahead and we need to do the exponent first. So let's figure out what 3e to the 8 squared is. So you type in 3, to get the e, you would do second comma 8, and then you just hit the x squared button. So you have 3e8 and the 2 with the exponent. And that will give you, that is going to give you 9e16. So you go ahead and take care of that squared. We need m by itself. It's being multiplied. The opposite of multiply is divide. And what we do to one side, we have to do to the other. So you get that m equals, and again, you would just you type in 3.04 second comma to get that capital E, negative 15, divided by 9 second comma to get that capital E, 16. You want to make sure that everything is cooperating. If you want to insert parentheses around each of your numbers, just to make sure that everything is being cohesive, you should get 3.38 if you round, e to the negative 32. Another way of looking at that would be 3.38 times 10 to the negative 32, and your unit for that would be kilograms. That should be kilograms there. So there we go. That is your answer. 5, what is the purpose of the control rods in the nuclear power plant? Basically what the control rods do, they absorb extra neutrons. They absorb extra neutrons that were produced by fission. And it's to kind of slow down the process. So it slows down the process. So, because it's absorbing those neutrons can't go and bump and cause more fission. So it slows down the process by absorbing neutrons. 6. Which fundamental force helps with fusion? That would be your strong. Strong force helps with fusion. If it's asking for fission, that'd be your weak force. But strong force helps with fusion. I believe that's it for nuclear. If you have any questions, make sure you ask Miss Heath or Miss Verona. You have 2 more videos to watch, and hope you have fun reviewing. Have a good day. Bye.